Welcome to this Instructable for the simple 60 LED clock. There is an LED for every second and minute on the display. The minutes are shown in green, seconds in white, and hours in blue. It's been designed so the light shines through to the wall behind as well as lighting the segment. Around the back you can see the microcontroller in the center, and wires out to the LED ring. There is a USB cable for power and programming the firmware. Look closely at the LEDs attached to the PCB. This step-by-step tutorial will walk you through TinkerCad Codeblocks, TinkerCad Design, 3D printing settings, and Tasmota firmware installation and configuration. Initial power on the time is 0. The clock checks the internet for the current time and sets it automatically. There you go, it's 9:17.
Okay, so here's how we make the second markers. Basically a block, a red block here, and some clear blocks that will be used to turn it into a wedge shape. We have 60 seconds, and the angle between each of those second markers is stored as this second rotation variable. And what we'll do is build that red block, create those two transparent blocks, and then rotate each of those by half of the rotation angle, and then of course we will remove them from the block. So now we have that wedge shape we need. We'll also create a wedge shape for the hour markers, so that's a taller block, and once we've got those blocks we can start putting them into a circle. So this loop here will build out all of the second markers. Let's just speed that up a little bit. So it basically creates a copy of that second marker object, moves it to the edge, and then rotates it by the number of seconds. So that will go around and that will create 30 second markers all the way around to the bottom. Now I'd love to be able to do all 60, but that goes over the limit of the code block's number of primitives. You can see the primitive counter going up here at the top. Apparently this code blocks program will top out at 133 primitives. Let's speed that up. Once it's done those second markers, it then adds the hour markers. So that is all of the markers for our clock. The invisible ring underneath is just shows the size of the LED ring, so you can see that fits within the LED ring. Okay, so now we're going to build the clock face itself. This is actually just a very simple cylinder, and what we're going to do is import those second markers which created. Now I'd already sized this disc appropriately. You can see this is now going to become the cutouts, the holes that will cut out from the clock face. Now as you can see, there's only half of the seconds are there, so I'm going to duplicate this shape with Control D and then rotate it by 180 degrees so we have the full clock face. So I'm going to select both of those and join them together, and so that's going to be used to cut out the second markers from this cylinder. So now if we bring this down, okay, so that's already at the 0 level on the canvas. What I'm actually going to do is bring this up by just 0.2 millimeters. So that means we'll have a very thin cutout, about one layer cutout, so that the light shines through easily. And so if we then combine these two shapes, we've now cut out those second markers. Good, so that's the cutouts for the LEDs. Now over to the side here, these are some pieces I created earlier, just to to finish off the clock. This piece is the LED ring itself, so let's bring that across by 200 and drop it down by 100. This just shows us how the LEDs would look. If I make this a hole so you can see through it, then you can see we've basically got a perfect cutout for the LEDs. So those white squares there are the LEDs, and that's a component I created before, which is basically a model of the LED ring. And you can see that slots in perfectly, and the light from those LEDs will light up that whole segment. Excellent. So that checks that that looks okay. Good. The other pieces to make the clock complete are all over here. So let's just bring those all over. I've moved them over by 100 earlier. Sorry, 200. Let's bring those back by 200. So you can see here kind of the exploded view of all the pieces. First we've got this outer ring. So this will provide, let's bring that down by -80. That provides kind of the standoff to hold it away from the wall when the clock's on the wall. So you can see that's about, I don't know, 20 millimeters high, something like that. So the light from the LEDs will actually backscatter and shine onto the wall as well by design. The little cutout here is so that the power cable can come in, and we can bend that cable around the corner here. That kind of gives a bit of a strain relief and stops the cable kind of pulling on the microcontroller. We also have a shape cut out here, and again let's bring that down by -20. So that's just really to make the clock look a bit more interesting from the front, just giving it a shape. And these little orange markers provide, again let's bring those down by -60, I think it was, no, -50. Let's have a look. So these provide a mounting for the microcontroller unit itself. So they hold their little standoffs to hold the microcontroller. Now you might be wondering, okay, how did I get the spacing just right for those? Well, basically I made a very simple model of the NodeMCU controller. I used a measuring device like a calipers just to measure out the spacing for the holes. Created these holes in it as well, and used that and some very simple kind of wedge shapes to build some mounts for the MCU. The final shape to drop down here is a mounting hole, and that will hold, let's see, bring that down by 100, yeah. Actually that can come up a little bit, there we go. That shape is just basically a cube with a cutout of a cone and a triangular shape, just to allow it to kind of hang off the screw. So if I now just move that LED ring out of the way for a second, so I'll move that out by 200, everything else we can group together, and that will create the final shape for the clock. There we go. So a mounting place for the microcontroller. I'll show you how that looks. Let's just group those things together, 1 second. So the microcontroller unit itself, you can imagine, will just sit on the back of the clock here. Now you might be wondering, why is it offset in a strange way? Well, the microcontroller itself has an LED in the center, so I marked out that LED. Actually this might be upside down, let's just turn it over 180 degrees, there we go. That's better. So you can see now, with this microcontroller mounted perfectly within these mounting holes, the circle in the middle here represents kind of the status LED of that microcontroller, and I've placed that so it's exactly in the center of the clock, so that when we look at the clock from the front, that cutout, let's just turn this into a hole, that cutout will show through and you'll be able to see the LED shining through there in the middle. Great stuff. So now we've built the clock, let's just have a look at how that LED ring looks again. I'll just turn this over so you can see what that looks like. That's basically a ring of 60 LEDs attached to a PCB. And you can buy this quite cheaply, solder it together, it comes in 4 pieces that get linked together. So let's turn it back over and put it back in the clock. So move that over by 200, which is where I moved it to before. Look at it from the top. There we go. So now you can see exactly how this should look. So there'll be the microcontroller here, the power cable will come in from the bottom here. This is just some space for the connector. There's a small cutout at the top here for the wires to the LED strip itself. Like I say, the mounting hole on the top. So really simple, LED ring, microcontroller, bit of soldering, and a single 3D print for the base. So talking of that, if I now export the clock itself, LED clock with Codeblocks STL, there we go, save that. And we'll open that up into the slicing program. Okay, so here's the design loaded up into Cura. So you can see on a single unit for printing all those holes for the LED light to shine through. In terms of slicing settings, I've just left it on a fast 0.3mm layer height, and standard settings 10% infill with a grid. Let's go and slice it and have a look through. So that reckons it'll be around 5 hours to print. The very bottom layer covers the whole surface of the clock, as you can see, and the second layer is where we start seeing the dividers coming in for the seconds. So there's just a single layer for the light to pass through. So using white PLA, the light should shine through that very easily. We've got like 2 walls there for the divider between the seconds, and again there'll be a little bit of light bleeding through there, which is absolutely fine. And so as we build up, you can see there's a grid infill there. Again, you can change the infill if you want to, or have thicker walls if needed. But that looks pretty good. And that goes all the way to the top. Now looking again at the 3D print, there are some different settings you could use that might give a better quality. So down on layer 1 here, if you set the bottom layer to concentric, you can see instead of going lines zigzagging across, you've now just got perfect circles. And then for the fill, you can also set that to concentric as well. And what happens is now each LED segment has horizontal lines across it, well, circular lines I guess, to go around with each of those elements. And as we go up layer by layer, you can see the infill is also circular as well. So that means it'll look a little bit more symmetrical, and the light should be more symmetrical on it as well. Alright, now it's time to install the firmware. We're using the Tasmota firmware, which is a fantastic open source firmware for these IoT devices. What we're going to use is the online installer, and all we need to do is hold down the flash button on the NodeMCU while plugging it into the USB. then select the release, which is say the latest release in English, 8266, click connect, connect serial port, click connect, and it connects to the device. Now it says install, so we click on install, erase what's on the device already, click next. Do you want to install? Yes, I do. Install. I'll let go of the flash button now while that's busy installing. And that's it. Installation's complete. That's the firmware loaded onto the device. So now I'm just going to look for Wi-Fi networks. I'm going to connect into my Wi-Fi, put in my password, and connect. And the Wi-Fi device will then be connected to my network so I can visit that device. So there we go. It's been given an IP address 192.168.0.133, and this is the main interface to control the device. Now what we're going to do is go through the instructions on the Instructable. We've installed the firmware, and now we're going to go through and configure the module. So the first step is configuration, configure module. We're going to set this to type generic, which is at the bottom of the list. Hit save. That will trigger the device to restart. Let's click main menu again, that's already restarted. Then we click configuration again and configure module. And now, because this is a generic device, we'll see lots more IOs that are now available. Now by default nothing is connected, so we're going to go through and connect these two. So pin D5 connects to internally to GPIO14. We're going to connect that to the LED ring, which is the WS2812, somewhere in that list. You can see it has a lot of different devices we can connect to. Here it is. And we're going to use the onboard LED, which is connected to D0, GPIO16, to be the status LED. And now that's an inverted output, so we're using LED I. Leave the default one. We'll hit save. And that's now saving. Configuration saved, and that's going to restart. Now while that's restarting, I'm just going to connect up the power and ground to the LED ring, and I'm going to connect the data to D5, and what we should have now is the ability to control the LEDs in the LED ring. So here's the wires connected, V in and ground, and D5 on the other side, and that connects around to the LED ring. So at the point I turn this on, the LEDs light up, and we can change the saturation, and we can change the color. Let's just turn this light off, and we can change the brightness. So there we go. So we've got a web interface to control the LEDs. But now we want to make it into a clock. And there's a few other things we can configure as well. So if we look at the other configuration panels, we have the ability to configure Wi-Fi. So here you can set up a secondary Wi-Fi network. So if you have a different Wi-Fi network to connect to, say the clock's going to be in a different location, you could put that additional Wi-Fi network details in there. We can also configure the name of the device. So I'm going to call this LED clock. And there was one more thing we could change on that, which was to to make this device appear like a Belkin Wemo device, which is basically a smart switch which we can control with a voice assistant, turn it on and off. And also give it a friendly name as well. Save that, and that will restart. We'll hit main menu again. Now to turn it into a clock, we're going to use some text-based commands. So we'll click on console. You can see here it tells us status of the device, what Wi-Fi it's connecting to, what the configuration is, the time and date, etc. And now we can enter text commands to go through the more advanced settings on Tasmota. Now Tasmota itself has what feels like hundreds of commands that we can set in terms of different configuration options. It's hugely configurable, and this clock mode is just one of many features it has. So you can see you can connect up different sensors, different timers, different scripting options. It's very powerful. But today we're going to use some commands I've already worked out. So if we use something called scheme 5 and press enter, that will make it. That instantly turns it into a clock. So you can see now the seconds are ticking away at the top there. We've got minutes and hours as well. Now the default colors are blue, red and green, but we want to change that. We also need to set the number of pixels as well. So right now it seems to have a few pixels. We're going to say we've got 60 pixels. There we go. Here we go, the current time 10:23. So let's have a look. So yeah, so that's the 10 o'clock, that's the 23 minutes past, and there's the second hand coming around. Now my current time is actually 9:23. So we need to change the time, change the time zone details. So we'll do that in a second. Before we jump to time zones, let's just change some of the other settings. The other settings here just change the look and feel of the device. Let's see if we can run all those at the same time. So we can only do one command at a time. Okay, so let's do status 7, fade on, and the LED state just tells us what status the status LED is going to show up. We can also change the width of the second to be 1, the width of the minute hand to be 3, and again you can choose any numbers you like here, and the width of the hours hand to be 3. And then we can also change the colours of those different markers. So if I want a white seconds and I want a green minutes and blue hours. There we go. So now we've got the white second marker, the green minutes and the blue hours. Now we also need to set the time zone, including setting the daylight savings. So if I set time zone to 99, that means it's going to use the following commands to set the daylight savings time, and this means last week of month 3, day 1, which I think is Sunday at 1 AM. So this is the UK spec, and this is the standard time, so Greenwich Mean Time, again UK spec. Last week of October. So that's now changed the time.
And that's it, we're finished. Enjoy your unique new digital clock. I hope you found this Instructable useful. Please comment and let me know if you build your own.